This is Finite Math A, and we are going to be talking about plurality with elimination, which is sometimes called instant runoff voting. Okay, so plurality with elimination, the first thing that you notice is that it has this word plurality. Remember that plurality means he with the most first place votes wins. The goal with plurality with elimination, though, is to find a candidate that has the majority of the first place votes. Now, often remember, we don't have a candidate with the majority of the first place votes. We only have a candidate who has the plurality of the first place votes. They don't have more than half, they just have the most. So what we're going to do is this. Step 1. If somebody has a majority of the first place votes, they are the winner of your election. You can stop. You don't have to do any more. If they don't, we are going to eliminate the least fit candidate, or in other words, the one that has the fewest number of first place votes. Whoever is in last place with plurality, basically. We're going to do this one at a time until someone gets a majority. Each time a candidate is eliminated, the next candidate on the ballot gets those first place votes. So what that means is if I have a candidate who has, let's say there's a column that has 15 votes, and it goes C, B, D, A. Right now, C has those votes. If C eliminated, we would give his votes to the person underneath so that those 15 people are still represented, and they say, well, if I can't have C, then I want my second choice. I want B instead. And we'll do this until somebody has the majority. So the first question that you need to ask is, how many votes is a majority? So for example, remember, a majority means more than half. That's important. It's not equal to half, it's more than half. So for example, if your total is 15, then a majority, see, half of that is 7.5. So majority, would be 8. Getting choked up here. Not great. And if you're talking about 10, if your total was 10, then half is 5, so your majority would be 6. So it's important every time that you do this that you find the majority first. Now in our case, we've got across the top of our election, we had 14 and 10 and 8 and 4 and 1, telling us that 37 people voted in this election. And 37 divided by 2 is 18.5. That's half. And since we need to have more than half, that means we need to have somebody get at least 19 votes. That would be our majority. All right, so that's always your first question. How many votes are a majority? And let's go ahead to the next page because we ran out of room. All right, so in this case, we know that a majority is 19 votes. That's what we're looking for. And we're going to start off looking at first place votes. So what I like to do is I like to circle the top place on every ballot, okay, because that's who I know is currently getting the points for that ballot. So right now, it starts off just like plurality. Step 1, A has 14, B has 4, C has 11, and D has 8. Now, it's important you write everybody down, even if they have 0 first place votes. If somebody has 0 first place votes, you want to say, like, D has 0, okay? And you will check and see, does someone have a majority? No, nobody has a majority. So we're going to eliminate the least fit candidate. So I look and I say, okay, who has the least number of first place votes? That's candidate B. I'm going to get rid of him. And then I'm going to go up to the chart, and I'm going to eliminate him from the chart. Now, the problem is that the 14 people are still being represented by A, these 10 are still being represented by C, these 8 still have D, and the 1 still has C, but these 4 people aren't being represented anymore. So I'm going to give those 4 votes to the person who's next down in the table, and those 4 votes are going to go to D. Now, again, I want to say it's not because D has the fewest, it's because that is who is next in the ballot for this particular set of candidates. All right. So that puts us with 3 people left. A has 14 first place votes. C has 11 first place votes. And now D has 12, because the 8 he had before and the 4 he got from B. And we ask ourselves, does anybody have the majority? If they have the majority, then we declare them the winner and we stop. If they don't, then we eliminate the least fit candidate. So right now, my least fit candidate is C. Okay, C has 11, so I'm going to go through and knock C off of this chart. C, 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 C. Okay. Now, these 14 people are still being represented by A, no problem, but these 10 aren't being represented by C anymore. So if they can't have C, they would want their next choice, who we've already knocked out of the race. So they would go down to the next available person in their column. Those 10 people prefer D. These 8 are okay. These 4 are okay. This one person, they can't have their first choice, so we would take down to their next choice, which is D as well. Now, sometimes when you have somebody who's first in more than one column, it will go to the same person like this did. Other times, it will have, like the 10 might go to A and the 1 might go to D. It just happens to be whoever is next down in that table. All right, so now A has 14 first place votes, and D is going to have an additional 10, an additional 1 that puts him at 23. That is a majority, so we would declare D our winner. Okay? And if you were going to rank these candidates, you would just rank by how long somebody survives. D was our winner, A was the last man standing, then C, and then B was the first eliminated, so he comes in last place. This would be called extended plurality with elimination. Now, when you go to do this in your homework, you need to do one of two things. You either need to carefully copy down the preference schedule so that you can mark it up like I did. So write down the preference schedule and mark it up. Or you need to write down the first column. The first row. If you write down the first row, then you can just keep adding to the person underneath it as you look at your book. Please don't mark up your textbook like I've marked up this place right here. Okay. All right, so how would you rank the candidates? Like this. As far as plurality with elimination goes, it cannot violate the majority criterion. That's good. It happens to violate the Condorcet criterion occasionally. It actually does in this election. Remember that C is a Condorcet candidate, but he did not get elected. D got elected in this election. So this is violating the Condorcet criterion. That's a problem. But the big problem with it is something called monotonicity. Okay, monotonicity. And this is our last fairness criterion that we're going to talk about. Okay, so here's what monotonicity looks like. Here we have 3 cities, Athens, Barcelona, and Calgary, A, B, and C, and they're competing to host the Summer Olympic Games. The final decision is made by a secret vote of the 29 members of the Executive Council, and the winner is chosen using plurality with elimination. 2 days before the actual election, a straw poll is conducted just to see how things stand. I think straw poll is one of your vocab words on your worksheet. Straw poll is basically an informal vote just to see how things stand. Okay, it's informal. The results don't actually count. It's just sort of a pre-vote to kind of see where you are. All right, so let's talk about plurality with elimination. There are 29 members. Okay, so we need to know what is a majority. If I take 29 and divide by 2, I end up with 14.5. Since I have to have more than half, I need more than 14.5, so I need somebody with 15. All right, I'm going to look at the first place person on each ballot. There are 3 contestants, A, B, and C. A has 7 from the first column and 4 from the last column. That gives him 11. B has 8, and C has 10. And I ask myself, did any get the majority of the first place votes? No. So since no one has the majority, I'm going to eliminate our least fit candidate, who happens to be B. So I'm going to go through my table. I'm going to cross off B. The 7, the 10, and the 4 are still fine, but now the 8 people are not being represented. So those 8 votes are going to go to the next person down in that column. Those 8 votes are going to go to C. Again, that has nothing to do with C having fewer than A. It's because C is who those 8 people would prefer if they can't have B. All right, that gives me 8. A has 11, and C has 18. That is a majority, and so C is our winner. Now, although the results are supposed to be the secret, word gets out that Calgary is going to win. So the 4 delegates represented in the last column decides to change their vote. So we're talking about these people right here, these 4 people. They hear that Calgary is going to win. They think that Calgary is going to win. And so they want to be able to say that they voted for the first place person. Oh yeah, I definitely elected them. Sometimes that's called bandwagon voting. Okay, I want to be able to say that I helped elect the person who wins. So they decide to switch their vote. So their ACB is now going to read CAB. Notice we already have a column that has CAB. So if I put these 10 and that together, that gives me now 14. Okay, so those 4 people switch their votes, and now we have a ballot that looks like this, CAB. All right, so I'm going to start again. A has 7 first place votes. B has 8 first place votes, and C has 14. Now that's not quite a majority. I can't declare the winner. He's really, really close to a majority of 15, but not quite. So I'm going to knock off the least fit candidate. This time our least fit candidate is A. So I'm going to knock A off of this table. The 8 and the 14 are still being represented, but that 7 would go down to the next person, which is B. So now B has 15 and C has 14, making B the winner. Okay, so this is what monotonicity does. Monotonicity is when you have a recount and the only changes are in the ballot are ones that do better for you. You should still win. So in other words, C actually got more first place votes the second time. He went from 10 first place votes to 14 first place votes. But because he did better, he lost. Another way to think about this is, let's say we have an election for class president, and you are elected in a straw poll conducted before we go to lunch. You have the most first place votes. You win our plurality with elimination election in the straw poll. During lunch, you convince 4 more people to vote for you instead of somebody else. And because you got more votes, now you lose. This is unfair. So this is called monotonicity. This is just a quirky thing that happens with plurality with elimination. It happens because it can cause a different person to be eliminated, so a different person gets extra votes. A lot of people would say that this is completely unfair, that it doesn't make sense that you can actually do worse by doing better. So by getting more people to vote for you, it causes you to lose. This is a fairness criterion we want to make sure that we are looking at anytime we have a recount. So monotonicity says if candidate X is the winner of an election, and in a re-election, the only changes in the ballot are those that favor candidate X and only X, then X should remain the winner. So in other words, it is only fair if X is our winner, and then X does better, and we recount the vote, we want X to still win. If X does better and X loses because of that, we would say that is not fair. That is a violation of the monotonicity criterion. All right, so that's our last fairness criterion. Let's do a couple of examples here. All right. Find the winner of the election using plurality with elimination, and then rank the candidates using extended plurality with elimination. All right, so I'm going to start off and I'm going to see what a majority is. 10 plus 6 plus 5 plus 4 plus 2. This gives me a total of 27. Half of 27 is 13.5. So a majority would be 14. Okay, so I'm going to start off A, B, C, and D. A has 10 first place votes. B has 6 first place votes. C has 5 first place votes. D has 4 and 2 putting together to give us 6. And while we've got this sitting here, I'd like to make a point. Let's say that C wasn't our least, but that B and D were. Like C had 12 or something like that. If you ever have 2 candidates with an equal number of votes and they are both the least, then you eliminate them simultaneously. You cross them both out and they just tie for that place. But that's not the case in this card. Nobody has 14 votes, so I'm going to eliminate C. 1. Okay, going to cross him off the chart. those 5 votes that he had will go down to the person underneath him. That would be 5 to B. All right, so now A has 10, B has 11, and D has 6. B has the 6 he had before plus the 5 he got from C. And I'm going to eliminate the least fit candidate because no one has 14 yet. So D has 6. I'm going to get rid of him. Here we go. I'm going to cross D off of this chart. Now the 10 are still represented, the 6 are still represented, the 5 are still represented, but these 4 can't have their next choice of C, so they would go down to the next person who's available, so 4 of those votes would go to B. In the last column, the next person down in the table is A. So in this case, instead of all 6 going to one person, the 4 are going to go to B because those 4 people prefer B over A. These 2 are going to go to A because those 2 people prefer A over B. All right, so that's going to give A 12 and B 15, making B our winner. Find the winner, B. And to rank them, okay, B would obviously come in first. Last person was A. D got eliminated next. And C was the first eliminated. So since he is the first eliminated, that makes him the last place person. Okay. All right. Okay, one more. Find the winner of the election using the plurality with elimination method. Then rank the candidates using extended. So I'm going to go through 25 and 20, 10, 30, and 10. That is 95 total votes. If I take that and divide by 2, I end up with 47.5, which means 48 is my majority. All right. And a candidate B, a candidate H, and a candidate S. Okay. So F has 25. B has 20, H has 10, and S has 40. I just realized I think I zoomed out of what you can see, so I apologize. I will scan back up to that last example, so if you need anything from that last example. When I zoomed, I lost my window. I apologize. Okay. So our least fit candidate, nobody has 48. S is close with 40. I'm going to eliminate H. Okay, so I'm going to go through my table. I'm going to cross off H. Those 10 votes are going to go to the next person down in the table, which is F. So F gets 10. That's going to put F at 35. B is 20. And S is 40. Again, nobody has the majority of the first place votes. Okay, so I'm going to eliminate the least fit candidate. Least fit candidate is B. I'm going to go through and cross B off of this table. Those 20 votes that had B at the top, those are going to go to F because he's the next person down on the table. That gives F 55 and S 40. Making F the winner. F is our winner here. And we would rank F, and then S, and then B, and then H. Okay, so to wrap this all up, a note on ties and tie breaking. It's important before you vote, and anyone votes, you decide if you're going to allow ties, and if not, you're going to decide how you're going to break them. A couple of common tiebreakers are most first place votes, head to head between the tied, first, fewest last place votes, etc. Chance has to be used for unbreakable ties. So for example, if you have one that says AB and one that says BA, and there are 4 people that said this and 4 people that said this. If you do most first place votes are the same. If you do head to head, you're going to get 4 to 4. That's the same. And the fewest last place votes will be the same as well. Okay, so we can't do that. So we'd have to use like a coin toss, rock, paper, scissors, etc. Academy Awards allow ties. There are lots of places that allow ties. So when you're talking about something like the Academy Awards, they use a board account method and they do allow ties. There have been instances in the past where in the Academy Awards you've had actors and directors who've had to share like Best Actor and Best Director as that award goes. As far as fairness criterion go, if we're going to decide if the election is fair, the first thing you would check for is, has the majority criterion been violated? If someone has the majority of the first place votes, then they ought to win. So you check to see, is there a majority winner? If yes, they should have won. If there was a majority winner and they did not win, then we say the majority criterion has been violated. Has the Condorcet criterion been violated? That says when compared against each other two at a time, a candidate is preferred to all other candidates. It's only fair that they win. So if you have somebody that never loses a head-to-head comparison, they ought to win your election. So the first thing you would decide is there a Condorcet candidate? So you would have to check all the head-to-head pairings. Okay, that's kind of a pain, but that's what you'd have to do, and determine, is there a Condorcet candidate? If they win, great. If not, then you would need to go on, you would say that has been violated. The monotonicity criterion and the independence of irrelevant alternative criterions all have to do with a recount. Okay. If you don't have a recount, then there's no issue here. But if you do have a recount, then you should check to see, did somebody do better and then lose? If somebody does better and it causes them to lose, then that would be monotonicity being violated. If somebody who is a loser drops out and it changes your overall winner, that would be our independence of irrelevant alternatives criterion. All right, and last thing, Arrow's impossibility theorem. All right, so in the 1940s, remember this is modern math, last 100 years here, we have a mathematical economist, Kenneth Arrow, and he discovered something really cool. For elections involving 3 or more candidates, there is no consistently fair method for choosing a winner. In fact, Arrow demonstrated, and this is what you probably ought to put on your vocab sheet, a method for determining election results that is democratic and always fair is a mathematical impossibility. That means that it doesn't matter how you count the votes, it can yield an unfair election. One or more of the fairness criterions could possibly be violated. There is no way to count the votes in an election with 3 or more candidates that is always fair. A democratic election is a mathematical impossibility. So let that sit there as you're thinking about the elections. And in the meantime, your job today, since I am not here, the first thing that you need to do is, if you have not done so, then you need to finish your board account homework from yesterday and expect that to be collected next time. You need to do the homework from section 1.4, which is the plurality with elimination. Okay. And if you get finished with Thing 1 and Thing 2, then you need to work on the Chapter 1 study guide. Okay. The next time I see you in class, we will work on our review guides and ask questions, and I'll collect these 2 homework assignments. We will work on the vocab. Don't forget that the vocab worksheet is due next class on the review day. So maybe that should be your number 3 here, and this should be number 4. Okay. Your vocab worksheet is due. You need to finish your board account and your plurality with elimination homework. Next time in class, we will review, and then we have a test coming up for period 5 on Tuesday, and our test for period 7 is on Wednesday of next week.